Hey folks, okay, I just want to spend a little bit of time talking about how we go about testing our programs, right? Eventually, at some point, we'll have a working program and we want to know whether it does what it's supposed to do or not, right? If somebody's paying us to write the program, then obviously we want to make sure that it's running before we give it to them because they're going to want to make sure it's running before they pay us. If you're turning in a program as part of a course assignment or project, then you want to make sure that it works before you turn it in to me because you want to make sure that you get good marks on it, right? So you're trying to think, whenever you're writing a program, you're trying to think about how exactly am I going to test this to make sure that it works? And that's what I want to talk about today. We'll just kind of introduce the topics today and see how we go. Testing is one of those skills that you get better and better at as you do more and more of it. But again, we want to make sure our programs work correctly, and the only real way to be sure that it genuinely works is to try it out, right? To try it on test cases that kind of test the limits of what it can do. So we want to make sure that it correctly handles valid data. So if it's supposed to go off and compute the distance between 2 points, we want to make sure that if I give it 2 points, it actually does compute the distance between it and gets the number right and prints it out right. So we want to make sure that it works correctly in valid cases, but we also want to make sure that it does its error handling and error checking correctly, right? If the program is supposed to check and make sure that the user actually provided a number, that the program really does detect whether or not they entered a number. So if they enter text, it detects it. If they enter some kind of invalid value, it detects it and displays an appropriate message and then takes the correct actions afterwards. If it's supposed to give the user 3 chances and then quit, we need to make sure that we have test cases that say, okay, well, if the user gets it right the first time, it works. If the user gets it wrong the first time but right the second time, it works. If they get it wrong the first 2 times but right the third time, it works. If they get it wrong 3 times in a row, it correctly stops. Right? We're trying to think of test cases that make sure it follows all of the behavior it's supposed to have. Now, as soon as we know the specs for a program, as soon as we have a description of what it's supposed to do, we can start thinking up these test cases. Right? Again, like I was just saying, if it's supposed to give them up to 3 tries, then right away we've thought of 3 test cases, or I guess 4 test cases. They get it right the first time, they get it wrong once, they get it wrong twice, they get it wrong 3 times. Right? So you can immediately start thinking of test cases, and as you go through development, you'll think of more and more test cases as time goes along. Now, for each of the test cases, there's a couple of things we want to think about. We want to think about, well, what information am I putting into the program for this particular test case, and what exactly should it do? So, on the one hand, I'm thinking exactly what sequence of characters should the user be typing in for this test case. And then I'm thinking about, okay, what exact sequence of characters should the program be spitting out for that test case? So I'm usually going to keep track of 3 things when I'm writing a test case. I'm going to have a reason for the test case. So this is the test case for checking if they get the value right the first time. This is the test case for if they get the value wrong the first time but right the second time. Something like this. A reason for that test, a motivation. Why am I including this test? And then the exact data that they would enter. So the first time they're going to enter foo, and the second time they're going to enter 12. Or the first time they're going to enter foo, the second time they're going to enter blah, the third time they're going to enter 27. So you're thinking of the exact sequence of input data the user is going to supply, and you're thinking of exactly what text output should the program produce when it's given that as input. And so what I'm going to do is for each test case, I'm going to have these 3 pieces of information written down. We're going to have these 3 pieces of information in a file or in different files so that I've got a record of that test case, what it's for, what I put in, what I expect to get out. And then when I want to do testing on the program, I can look at each of my test cases and say, okay, now let's run this test case and see if it works. Worked for that one. Okay, now let's run this other test case and see if it works. And I've got the exact sequence of input data to use and the exact output I'm expecting. And I've got a reason for that particular test. And so the idea is every time I come up with a new version of my program, every time I modify my program, I'm going to go back and run all of these tests to see if it works on all of the test cases, to make sure that it fixed the, whatever the latest bug is I was trying to solve. and that I haven't broken anything else. Because that's the other thing, is if you fix one bug, it's not unusual for you to create another one, right? So all of a sudden it fails a test case it used to pass. Now, doing this manually, if I wind up with 20 or 30 or 50 test cases, or as we get into more complex programs, hundreds or thousands of test cases, it gets to be a real pain to type it in by hand every time, right? It's easy to make mistakes, it's easy to forget a case, it's easy to kind of mix up, get the, I'm looking at the input data and I'm writing in the input data for one test case, and then my eyes kind of wander and I look at the output that's expected for a different test case. It's really difficult to do it correctly manually over and over and over and over and over again. So we want to try and automate it a little bit. So one of the things that we can do is to put the input data that we want the user to use or to enter into one file. So we'll actually have it stored in a file someplace, just regular old text file. So use Pico or Vim or whatever your favorite editor is, and put the user input, the things that they would actually type, into the file. And then in another file someplace, we'll put the output we expect the program to produce. Now, when I run my program, I can tell it, okay, don't read input that the user's typing. Read the input from the file and use that instead. And I can even tell it, instead of dumping the output to the screen, dump it into another file. So if I've got my program, my executable, and I want to run it and have it read input from a file and put the output in another file, I can use this command. And so this way, I'm not actually trying to type it all in every time. It's just I've got this file that's got the input data in it, I can just run it. And again, if the input gets long and complex, that saves you a lot of time and a lot of typing errors. And I'll store the output someplace. And then if I've got this other file, whatever I want to call it, that has the output I'm expecting to see, I can compare the two of them. I can compare the output that was produced with the output I was expecting. And there's a program called diff that does that for you. If you say diff and you give it two files, it compares the two files line by line and tells you which lines are different. So now all of a sudden I've got these two commands where I run my program on this kind of stock test case that I've put in a file someplace, and I do a diff to see if it got exactly the output I was expecting. And by typing those two commands, I've avoided all of the kind of manual comparisons and errors that might crop into that, and all of the manual input and the errors that might crop into that. Eventually, we'll look at, say in 265, for instance, the software engineering course, we'll look at putting these into scripts someplace where I can have essentially another program, another script that just goes through and runs all of my test cases all at once. So again, just as an example, suppose the behavior that we're expecting from the program is it's going to ask us to enter an hour between 1 and 12. The user's going to type in something. It's going to ask us to enter a minute between 0 and 59. The user's going to type in something. And then it's going to print out the time formatted however we like. So this is what the program's supposed to do. So I'm immediately going to start thinking of test cases for this, and I'm going to start creating files for them. So the test case for that one would be, our input file, we'd put the 10 and the 27 in one file, and then the expected output would be what the program is supposed to see out. So in this case, it was supposed to see out that first prompt, the second prompt, and for that test case, that final output it should produce is this. So we have our input file that's got the 10 and the 27 in it, and our expected output file that's got exactly what we expect the program to see out. And then that diff command would show line by line any differences between the output it actually produced and the output we were expecting. Now note that the output is just the things that the program is supposed to see out. So it doesn't have the user input embedded in between it, however. And again, we'll start thinking up test cases. For something like this, it was telling us that the hour is supposed to be in the range 1 to 12, the minute in the range 0 to 59. So I want to start thinking, okay, well, I'm going to have one test case that has 1 for the hour, right, the smallest valid value, another test case that's got 12. I'm going to have a test case that has 0, the smallest valid minute, for one that's got 59. I'm going to do error checking and try something that's just outside that range, right, a 0 and a 13, or a -1 and a 60. I might throw in a test where they type in complete garbage for the hour, foo for the hour or foo for the minute. So I'll have these test cases that I'm dreaming up, and for each of them I'll have an input file and an expected output file. So when we're looking at the sample output, again, the expected output should reflect the error messages we think the program should give, the data values that it should have, right? Everything exactly the way we think the program should spew it out. So these are things I want you to get into the habit of thinking about, because this is the kind of thing that I'm doing when I'm marking your programs. I'm looking at the specifications for a program, what it's supposed to do kind of as a description, and I'm creating a whole suite of test cases to try and exercise all the different features to see if they all work. And then actually in my case I'll have some automated scripts set up to run all of the test cases on all of the programs and tell me which ones are right and which ones are wrong, and then I go through and look at your code and all that kind of thing. But again, this is a really good habit to get into, and the more you do it and the earlier you start practicing this, the better you will get at it. And again, in terms of automating all of this, in the software engineering course, we'll explicitly focus for a chunk of the course on how we develop test suites, how we apply them, and how we evaluate them. But it's a good thing to have in the back of your mind now. All right, I will leave that there for now.